Hey geometry class, we're going to be going over chapter 9, all the lessons in it, because we can put them together in a pretty condensed form and not worry about some of the things that are actually in chapter 9. It's not going to be too long. So what this chapter is over are transformations. Here's the definition of transformations. Transformations are the change in position or size of a figure. Types of transformations are translations, reflections, rotations, and dilations. And we're going to be looking at each one of these things right here as we go throughout these lessons. Okay, first thing that we have come to is something called a translation. And a translation, I have the definition written out here. Transformation in which a figure moves left or right, up or down, or a combination of those two things together. And then many students get these two things mixed up, but let's start with pre-image. Pre-image is the original figure that you were given. And then the image is the figure after you apply a transformation. Okay. This right here, this notation, we're going to be using for our rules of our translations. This is a translation rule right here. The way you can tell this is a translation is because you're either going to be adding or subtracting a value to your x and adding or subtracting a value to your y. So translations means you're adding or subtracting a value from your x and y. We're going to get into something where we're multiplying something to our x and y. That is something else. That's a dilation, and we'll get to that in one of the last slides we're going through. But here we go. We're going to translate this figure right here that I've already drawn out for us. And where I get that figure is this right here. My value of A is negative 2, 6, so plot it. B, 2, 4, plot that. C, 2, 1, I plotted that. And D, negative 2, 3, plotted that. So our translation is going to happen with this rule that we're given right here. So for any translation that you are given, you're always going to be given a certain rule for that translation. And for this particular figure, we are asked to use this one. So we're going to add 3 to x and subtract 3 from y from each of our given points on our figure that are the vertexes on our figure. So let's do this translation. So negative 2, 6 becomes F1, 3. And then the 2, 4, add 3 to 2, you get 5. Subtract 3 from 4, you get 1. And just keep going. 2, 1 becomes 5, negative 2. And negative 2, 3 becomes 1, 0. Now, once you're done figuring out the points that you need to plot them. So for A, this little notation right here, I call that prime. For A prime, we're going to plot the point 1, 3. So 1 up 3. And then for B prime, 5, 1. Right here. So label it B prime. C is 5, negative 2. So 5, negative 2. And then D is 1, 0. 1, 0. And then you just connect the dots. And you see how the figure did not change in size or shape at all. It just simply moved over to the right so many units and then down another so many units. And those are the units here given to us. Alright, for example 2, we're asked to use this translation that we are given. Here's our translation rule. And answer these two questions. What is the image of this point given to us right here? 3, 2. Well, if we follow this rule right here, and we're asked to find the image, just apply the rule. So our A prime is going to be our 3 plus 6, comma, 2 minus 3. And then add and subtract those values together, and you get 9, comma, negative 1. And you're done. So this next one, it says, what is the pre-image? So we are given this right here. We are given the image, so we're going to work our way backwards. And how we work our way backwards is we apply this rule, but in reverse. So kind of our rule to find what f, not f prime, but f is, we are going to use this. F is going to be x minus 6, y plus 3. So whatever these are in between, do the opposite. Okay, so for this one down here, our f is going to be negative 3 minus 6, negative 4 plus 3. So do the math on that one, and we get negative 9, negative 1, and we're done. Okay, so here are the coordinate rules for reflections. So we moved on to reflections, and a reflection is another transformation that uses a line as it's a mirror. So you're going to be reflecting things across different mirroring lines or different lines of reflection. So here are some coordinate rules. We're going to be using these 4 things to reflect across. We're going to reflect across the x-axis, the y-axis, the y equals x, and y equals negative x. So follow these rules. So if you're reflecting across the x-axis, your point AB becomes the point A, negative B. And then if you're reflecting across the y-axis, that point AB becomes negative AB. And now if your reflection line is y equals x, AB becomes BA. And then if you are reflecting across the y equals negative x, it becomes negative B, negative A. So follow these rules right here to help you in figuring out where your image, the points of your image, are going to be located. In this example, we were asked to use the reflection rules and reflect across the y equals x. So this is our rule that we have for reflecting across y equals x. If we have the point xy, to get the reflection of xy, we switch the two values. It becomes yx. Okay, I'm going to draw in this line we are reflecting across. Y equals x is this line right here. And then let's do the rule and apply it to each one of these points we are given, H, I, and J. So H prime, our image, is going to be, switch these two values, -3, 3 becomes 3, -3. I becomes 2, 1, and J becomes 1, -2. So now let's plot these points. So here are the points plotted. I went ahead and did that. And the next step is just connect the dots. So I'm going to connect them. Okay. So maybe you can see this a little bit better, that this is the reflection of that HIJ across the line I drew, y = x. You see how the distance between, let me get out of, between here is the same. Between here and that line, then here and this line, are the same. And same goes with this one right here. They are all in line with each other. Alright, so example 4 again, we are dealing with reflections, and we're asked to, it says, point A is located at 4, -7. The point is reflected across the x-axis. Its image is located at, and we're supposed to choose one of these 4 points that we are given. This is a multiple choice problem. So, if we follow our rule that if we're reflecting across the x-axis, our point that is located at AB becomes the point A, -B. And if we look back here, 4 stays the same, so 4 and then -B. So -7, so +7. 4, +7 is this one right here. Now let's look at this other one. It says, what are the coordinates of point P? The image of point 3, -4 after the reflection in the line y = x. So if we're reflecting across the line y = x, our image and pre-image, this is the rule for it here. We just switch A and B around. Even whenever we're going from the pre-image to the image, we switch A and B, and back to the, from the image to the pre-image, we're doing the same thing. We're switching A and B. So this point right here that we are given, if we're reflecting across the y = x, switch the values around. So that becomes the point -4, 3, which is number 4 here. Okay, so here are some definitions for rotations. If you did not write this down in class, get this down right now. A rotation is a transformation in which a figure is turned about a fixed point. And that fixed point is called the center of rotation. So that's what our definition is. The angle of rotation is a ray from the center of the rotation to a point and its image. So here is what we're going to be looking at for this. Is like we're looking a little bit closer at what is center or angle of rotation. We are given a fixed point, and this is a ray coming from our image, or this ray is coming from our image, and we are rotating around that fixed point to come up the other image. The angle right here is our angle of rotation. So in this one right here, this example, we're asked to match the diagram with the angle of rotation. So here's our angle, here are our angles of rotation: 60, 130, and 95 degrees. So this one right here, 130 degrees, that's an obtuse angle. So pick the one that looks obtuse. So number 1 is answer B. And then number 2, that almost looks like a right angle, so I'm going to choose 95. So answer C is that one. And then the last one is an acute angle. The only acute angle we have is 60 degrees, so answer is A on number 3. Alright, so here we have some coordinate rules for rotations about the origin. Whenever we are going to be using rotations for any figures, these are the 3 rules that we're going to apply. We're going to either rotate it about the origin 90 degrees, 180 degrees, or 270 degrees. If you're asked to rotate it 360 degrees, well, that's just the image itself. You've came all the way back around to the original image that you have. So let's look at these rules. We have for a rotation of 90 degrees about the origin, we're going to have our point AB is going to become negative B A. And then for the rotation of 180 degrees, our point AB becomes negative A, negative B. Then the rotation for 270 degrees, our point AB becomes B, negative A. So here is our point AB right here. Point AB. If we rotate this at 90 degrees, this is a full 90 degrees right here, because that right there creates a right angle. But anyway, if we rotate that full 90 degrees, we come to the point negative BA. Now, rotate that another 90 degrees. We're following this rotation for 90 degrees. Rotate this point right here another 90 degrees. Follow that same rule. Our negative BA that we have here, switch them around again and put a negative on it, on that second value A. We get negative A, negative B. So we get the rotation for 180 degrees, because 90 plus 90 is 180. So from this original point, AB, 180 degree rotation all the way around, comes negative A, negative B. So, and it keeps on going around to this point here. Okay, so let's look at some more things here about rotations. On this example right here, I had to add in a little bit of my grid because it's going to go off the grid a little bit. So if you want to do that on your paper, please do. We're going to rotate this figure about the origin by the number of degrees given. So the number of degrees given is this right here, 180 degrees. We're going to rotate all of this, all 4 of these points 180 degrees to get our figure. So let's go ahead and write these out. So D, E, F, G. And we're going to find their images. by using the rule of 180 degrees. Now the rule for 180 degree rotation is this right here, our point AB that we are given. So each of these are our AB. We are going to take those points and use this, negative A, negative B. Now, D, our point 0,4, becomes, well, negative 0 is still 0, and then negative 4. So any value, just to let you know, that is negative, if you're putting another negative on it, they cancel each other out basically. And negative negative B becomes positive B. Alright, we don't have that in this case right here though. All of our X and Y values are positive. Okay, so E. 2, 7 becomes negative 2, negative 7. And then F, 6, 4 becomes negative 6, 4. And then G becomes negative 2, negative 2. Now let's plot these points. Alright, so I've plotted my points. You can go ahead and pause this if you want and get these same points down, but you should know how to plot these points now that we had found them together. And you can see, hopefully, that this figure right here from the origin has rotated a complete 180 degrees. Okay, so that's what we're doing, 180 degree rotation. And you'll do some other rotations in your homework that I've asked you to do. Okay, so here's just a rundown of the things that we have looked at. So to remind you, transformation. The word transform means to change. So we are changing our figures in the way of these three types of transformations right here. A translation, which is sliding it along the graph, up, down, left, right, or both, of some combination of those. And then a reflection, so reflecting across X, Y axis, or the Y equals X, Y equals negative X, something like that. And then the rotation, so we are turning it around a certain point. And then let's see. Something else that we need to know is a vocabulary word is called an isometry. An isometry is a transformation that preserves side and angle measurement of our figure. So all three of these right here, translation, reflection, and rotation, are all isometries. You did not see anything about the angle measurements change or the side lengths of the shape change at all. They should have stayed the same. Otherwise, something went wrong with the translation rule or some other transformation rule that you did on your figure. The only other type of transformation that I have left is called a dilation, and that's what we're about to look at. Here are the coordinate notation for a dilation. You can describe a dilation with respect to the origin with the notation of this right here. So here's our rule. Our xy, it becomes k times x and k times y, where k is something called the scale factor. And right here is another part of it. If we have our scale factor that is between 0 and 1, so some sort of fraction like or decimal point like 0.4 or 1/2 or 1/4, something that is very small between 0 and 1, we're going to have a dilation called a reduction. This is going to make our image smaller. And if we have a value of k that is greater than 1, we call this dilation an enlargement because this makes our image bigger. So, a dilation is or is not, I want you to circle one, an isometry. And well, the answer on this one is because our figure gets either smaller or bigger, the size of our shape changes. Not necessarily the angle. The angles aren't going to change, but the shape, the size of it is going to change. Therefore, the side lengths change in the shape and does not meet the definition of what an isometry is. An isometry preserves the length measurements and the angle measurements. And in a dilation, that length is not preserved. So on this one, just circle is not. Alright, in this example, I already have the image, a pre-image drawn for us that we are given right here. We're given these points. So I went ahead and plotted them for us. As you need to do the same thing on your paper. And then we're going to follow this right here. We are given that the dilation we're asked to use is 2. The dilation of 2. That 2 right there is our scale factor. So in our rule that we have xy points, it's going to change to 2 times x and 2 times y. So we're going to be multiplying all of our x and y values that we were given up here by 2. So a becomes -2, 6. B becomes 4, 0. C becomes 4, -2. And then D becomes -6, -2. Now we're going to plot these points. I'm going to pause it for a bit until I get my points plotted. You do the same. Alright, so in our image, what should have happened whenever you drew this out is none of the angles actually changed. All these angles, if you measure them out with a measuring tool of some sort, you will see that all your angles are the same. What did change is all the side measurements of your figure. They got larger by a factor of 2. So it doubled in size. And that is what a dilation is, or in this case, an enlargement. I believe one of your problems, whenever you get to the dilation portion of your homework, you will have a scale factor that is between 0 and 1. So your figure is going to get smaller rather than bigger, like this one did. But that is all I have for you. I would like for you guys to work on your homework in class tomorrow, and if you have any questions, come by and see me. And I will see you later. Goodbye, everybody.